Hey, hello friends, my name is Vikas Verma and today I am going to discuss a very common problem that mostly people do while solving the problem using the binary search. So to explain the issue or the bug mostly people do, I am going to take one common problem from the Leetcode, that is problem number 278, finding the first bad version. So to explain the problem statement, let me take an example. Let's say I'm an Android developer. I have uploaded my first Android application to the Play Store and give it a version 1 to that. And suddenly, people started liking my video and giving more suggestions and improvements to me. So I started making the more upgraded version and give the version number 2. And for next version, I give version number 3 up to, let's say, version 6. But suddenly, I got to know that while testing my version 6, there is some issue that while giving some input, I'm getting some exceptions. So I want to fix the issue as soon as possible. But I don't know from where my first bad version happened. Let's say my first bad version happened at version 4, but I want to find it. So how I can do that? So to find the bad version, I have given one method, that is bad version, in the problem statement. If you pass any version, it can throw any exception or giving a true false value so that you can understand this is the bad version. So that's how you can figure out which version is the bad. But I want to find the first bad version so that I can fix all the bad versions and make my application good. Alright. So let's say my first bad version is 4, and if I pass 4 to this bad version, it returns true that yes, it is a bad version. And all the version after that, if I pass 5, it will also return true that yes, it is a bad version, and for 6 as well. But if I pass 3 to this bad version, it will return false that it is not the bad version. And if it is not the bad version, also that it means these versions are also not bad, right? So I want to figure out the first bad version, how I can do that. So the first simple solution to do that is to do a linear search on my problem space. Let's say, just check, is 1 is the bad version? No, 1 is not. 2? No. 3? No. 4? Yes, 4 is the bad version, just return 4. And you get the solution. But it will take a linear time to solve this problem. Alright? It will going to search all the versions, and when it finds the first bad version, then it will return. Right? Can we do better? As title suggests, we can solve this problem using the binary search. Alright, so here is the solution that I have built for this problem statement. I am going to explain the solution with the example first, and then we will see what is the issue with this solution. Okay, so let's say for binary search, we want our problem space should be in the sorted form. Yes, our versions are in the sorted form. It can never be happen like I built version 6 first and then version 4. These always be in sorted form, alright? So in binary search, what we initially do is, let's say I define my first version as a left and my last version is right. No, this n would be my current version. So my current version is 6, alright? So to find the first bad version, in the binary search, we always first find the mid value, and then we will see whether we want to go to the left side of my problem space or to the right side of my problem space, right? So here, as for the equation, we need to do left plus right divided by 2. What is my left? Left is 1 plus right, and then divided by 2, and it will give me a 3.5. But as we are using integer here, so it will become a 3. So now we check whether 3 is the bad version or not. Okay, we pass the 3 here in this method, and it will return false. No, 3 is not the bad version. So we know that all the versions before 3 and including 3 as well are not the bad version, right? So now our problem space should be limited to just the right hand side of the 3. We divide the problem into the half. Right? Now we check okay, now we make left as a mid plus 1, that is 4. Now our 4 is the left. Alright, now if we find the mid value, we will get 5 as a mid value. So we know that if you pass 5 to its bad version, it will return true, right? It is the bad version. So now we know that all the versions after the 5 is the bad version, because if 5 is the bad version, all the versions after that also the bad version. So now we know that either 5 is the bad version or the first bad version exists at the left side of the 5, right? So our problem statement now restricts to just within these two values, right? So we make our right as mid and we run this program again, and now we find that 4 is the first bad version. So this program will perfectly run fine with this column space. When our current version is just 3 or maybe just 10, 12, 200, it will work just perfectly fine. But the issue is when we make our n as an integer maximum value, let's say our n is the integer maximum value, then what will going to happen when we find the mid value? So let me quickly rub this. Tell you the issue. So now let's say if I just add left is 1 and right is 2 to the power 32 minus 1, then what will happen? So if we add 1 with integer's maximum value, as integer maximum value is this, it will never going to fit into the integer, right? So it will start giving you a negative result, negative values. And so if it will give you a negative value, our mid will become a negative and you will get the unexpected result from this program. So that's the issue with this statement. And mostly people make this mistake, they just write left plus right and divide by 2 and get the mid value. Yes, this will work with a smaller problem space, but with a bigger problem space where n is an integer maximum value, this won't work. Now let me quickly explain you what is the issue internally happens so that this number becomes a negative number. Okay, let's take for example, I'm taking a byte as a data type b where the value is 127, and we know that in the Java a byte represents one byte, that is 8-bit, and that can value up to 128 up to 127. Alright, so if we increment the 127 plus 1, it will give you minus 128. Alright, so now in the form of binary representation, this 127 actually represented as 0, 1, 2, 3, 4, 5, 6, 7. This is the binary representation of 127. And if we increment it by 1, it will give me the result. This will be the binary representation, and this is actually a binary representation of minus 128. How? Because in computer programming, in integer value, the most significant bit actually represents the sign value of the number. If it is 0, it means it's a positive value, and if it is 1, it means it is a negative value, the most significant bit. Alright? So that's why this number is become 127 if I increment it by plus 1. And the same thing happens when we increment integer with the maximum value. Let's say integer value is the maximum value, and if we increment it by 1, it will give you a negative result, the negative maximum value of the integer. So that's the problem that happens here with this equation. Alright, so now let me explain you the solution, how we can solve this problem. Alright, we can just solve this problem with a simple statement like this. This statement also gives the same result as this. Alright, if we just do the left plus right minus left divided by 2. So now let me explain you how this equation works. So for example, let's say left is 1 and the right is 6. Alright. And what this right minus left divided by 2 is doing is they're just finding the mid value of this problem space. Alright. And now this will give you 6 minus 1 divided by 2, which gives me 2.5, but as we are using integer it becomes 2. Now we know that mid value between 1 and 6 is 2, and if we just simply increment left with 2, we will reach to the mid value, right? We will reach to the mid value, right? That is 3, and the same result we get from this and this, right? So this is the solution of the binary search. So whenever you solve any problem using binary search, always use this equation to find the mid, not this, because for the bigger problem space where integer value is integer's maximum value, you will lead to the unexpected result. So always use this equation whenever you're solving problem with a binary search. Okay, so that's all from this video. If you really like this video, please give us a thumbs up. That will motivate more to give you more videos. And if you really want to improve anything in this video, please give the comment below so that I can improve those into my next video. Thank you so much.